Welcome to video 2 for this unit on dilations, similarity, and introducing slope. In this video, we're going to focus on similarity. Here are similar triangles A, B, C, and D, E, F. Two figures are similar if one figure can fit exactly over the other after a sequence of rigid transformations and dilations. Rigid transformations include translations, rotations, and reflections. There are many correct sequences of transformations. What sequence would you choose to show that the two triangles are similar? One way to show that triangle ABC is similar to triangle DEF follows these steps. Step 1. Reflect across line F. Step 2. Rotate 90 degrees counterclockwise around D. Step 3. Dilate with center D and scale factor 2. The transformation of ABC fits exactly over triangle DEF. While there are many more correct sequences of transformations that take triangle ABC to triangle DEF, we only need to describe one to show that the two figures are similar. Consider the two rectangles shown here. Are these rectangles similar? When two polygons are similar, every angle and side in one polygon has a corresponding part in the other polygon. All pairs of corresponding angles have the same measure, and corresponding sides are related by a single scale factor. This means that each side length in one figure can be multiplied by the scale factor to get the corresponding side length in the other figure. It looks like rectangles A, B, C, D, and E, F, G, H could be similar if you match the long edges and match the short edges. All the corresponding angles are congruent because they are all right angles. Calculating the scale factor between the sides is where we see that corresponding angles and looks like isn't enough to make them similar. To scale the long side AB to the long side EF, the scale factor must be 3/4, because 4 times 3/4 equals 3. But the scale factor to match AD to EH has to be 2/3, because 3 times 2/3 equals 2. So, the rectangles are not similar because the scale factors for all corresponding sides must be the same. When the polygons are triangles, we only need to check that both triangles have two corresponding angles to show that they are similar. Can you tell why? Here is an example. Triangle ABC and triangle DEF each have a 30-degree angle and a 45-degree angle. We can translate A to D and then rotate so that the two 30-degree angles are aligned. Notice how corresponding sides AB and DE are aligned, along with corresponding sides AC and DF. Now, a dilation with center D and appropriate scale factor will move C' to F. This dilation also moves B' to E, and the pair of 45-degree angles align, showing that triangles ABC and DEF are similar. No matter the measurements of the two pairs of corresponding angles, we can always use a sequence of transformations like this one to first line up one pair of corresponding angles, and then use a dilation to line up the other pair to show that two triangles with two pairs of corresponding angles are similar. If two polygons are similar, then we can multiply the side lengths in one polygon by the same scale factor to find the corresponding side lengths in the other polygon. For these triangles, the scale factor from the smaller to the larger triangle is 2. That is, we can multiply the value of any side length of triangle ABC by 2 to find the value of the corresponding side length in triangle A', B', C'. Here is a table showing the lengths for the medium and short sides of each triangle. Since these triangles are similar, there is another feature they share. The lengths of the medium side and the short side are in a ratio of 4:3. This means that the medium side in each triangle is 4/3 as long as the short side. We can show this for any pair of sides. For example, the lengths of the long side and the lengths of the short side are in a ratio of 5:3. This means that the long side in each triangle is 5/3 as long as the short side. This is true for all similar polygons. The ratio between two sides in one polygon is the same as the ratio of the corresponding sides in a similar polygon. We can use these facts to calculate missing links in similar polygons. For example, triangles D', E', F' and D, E, F shown here are similar. Let's find the length of segment E', F' using what we already know. In triangle DEF, side EF is twice as long as side DE. So this must be true for any triangle that is similar to triangle DEF. Since D', E' is 1.2 units long, and 1.2 times 2 equals 2.4, the length of side E', F' is 2.4 units. Thank you for watching video 2 of 3 for this unit on dilations, similarity, and introducing slope.